This is an example of solving a triangle that is not a right triangle. So let's put our information in. I've drawn just a general ABC triangle. I try to make sure that none of them are right angles so we don't think to use standard trig ways of solving this. So the first thing that I would do is put the information into the picture. Side A is 8 centimeters. That's opposite of the vertex A. So this would be 8 centimeters over here. Side C, opposite of the vertex C, is 13 centimeters. And we're given the included angle here of 100 degrees. So the setup here is side angle side. And when we're dealing with side angle side, we're talking about the law of cosines. So if we're talking about the law of cosines, and we're going to be looking for the opposite side to be, that's what law of cosines is going to do, because we have angle B, we're going to set up the law of cosines as b squared equals a squared plus c squared minus 2ac cosine of 100 degrees. So basically cosine of b. The b's have to be on opposite ends of this equation. So if we were looking for side A, we would put A here and vertex angle A over there. Alright, so let's plug in all our information. B is the side we're looking for, so we'll leave that alone. A squared is 8 centimeters, so 8 squared. C is that 13, and then minus 2 times 8 times 13. And then finally cosine of that 100 degrees. Now to solve for B, all we're going to have to do is type all this mess into a calculator, get an answer, and then square root it. So after typing into a calculator, you're going to get approximately b squared is 269.1 and a few other decimals. And if we square root both sides, we get b is approximately 16.4 centimeters. Now to solve for the rest of it, this side becomes 16.4 centimeters. To find one of the other angles, once you find one of the angles, you find the other. We can set this up with the law of sines. So the side we're looking, the angle we're looking for, let's go for A, why not? So over here to the side, we'll do sine of A over side A. And again, I'm putting sine of A on top because we're looking for an angle. If we're looking for a side, I'd put a side on top, just to make life easier. And then take the given information that we have, which was the sine of 100, it's the only angle I have, and its opposite side, which we just found, which was 16.4. And then we're going to get sine of A is equal to 8 sine of 100 over 16.4. And then sine inverse both sides, we're going to get A is approximately the sine inverse of 8 sine of 100 divided by 16.4, which is approximately 28.7 centimeters. Or I'm sorry, it's not centimeters. We're solving for an angle here. So angle A is 28.7 degrees. So be careful what you're solving for. You'll forget what measurements they're supposed to have. And then obviously you can find angle C, add those A and B together and subtract from 180. Alright, the other possibility with law of cosines is if we give you all three sides. This would be side, side, side. It proves a congruent triangle, so that would be also law of cosines. So label our sides. This side is 12 centimeters, side C is 25 centimeters, side B is 15 centimeters, and it doesn't matter what angle you go for, but the standard setup is looking for angle C. So set up law of cosines with angle C. We're going to have C on this side, so C squared equals A squared plus B squared minus 2AB cosine of angle vertex at C. Alright, so plug in what we know. C is 25, so that would be 25 squared equals 12 squared plus 15 squared for A and B minus 2 times 12 times 15 times cosine of C. The easiest way to solve this is just to switch the places of this piece and this piece. When you flip them, this one's going to become positive on this side, and this one's going to become negative on that side. So basically, you're just switching them. And I'm just going to figure out what 2 times 15 times 12 is 360. So when I rewrite this, it's going to be 360 positively cosine of c is equal to 12 squared plus 15 squared minus 25 squared. And then we'll get 360 cosine of c is equal to negative 256. Ooh, that's an ugly 5. And then to solve for c, we're going to divide both sides by 360. We're going to get cosine of c is negative 256 over 360, and we're going to take its inverse. So cosine inverse both sides. So we're going to take cosine inverse of this ratio, negative 256 divided by 360. And if you remember about cosine inverse, it works in the first and the second quadrants. So this thing being negative is going to force the angle into the second quadrant, which makes angle C an obtuse angle guaranteed. So the answer we should get out of this should be an obtuse angle. And we find that angle C, the measure of angle C, is approximately 135.3 degrees. Alright, and then if we want to go searching for one of the other angles, say we want to go searching for B, again we would set up law of sines. We could say sine of B over 15 equals sine of 135.3 over 25, and go through and solve for B. So that's not a big deal. And again, once you get B, A is simple. And that's it. Law of cosines.